Okay. Everyone here? Everyone in? Are we good to go? It's that time again. Oh, not this time. Oh, no. Okay, start again. Okay, hi, everyone. Welcome to the IPFS Meetup. Today is Tuesday, March the 23rd. I am Alan. Pleased to meet you. I'm an engineer at Protocol Labs. Today, we have some speakers. Woof! Welcome to our speakers. But first, a few reminders. This event abides by the IPFS code, community code of conduct. If you don't know where that is, then search for it on Google, and it comes up as a first result. And please read it. Please be good to your fellow friends in the IPFS community. So if you have questions, please ask them in the chat. You'll need to click at the bottom, and then it will be on the right-hand side. If you are interested in other things that happened, the other events that we did, then please check out the IPFS YouTube page. It's pretty rad. I've got loads and loads of content on there. And if you would like to speak at a future meetup, then give us an email, send us an email even, ipfs-community@protocol.ai. All right, let's get on with it. What else have we got? So today we have some speakers, some awesome speakers today. First up, we're going to have the Scala Project talking about how to secure a blockchain using IPFS. And then we have Daniel Buchner talking about Ion V1 launch and a look beyond. Next up, we will have Ceramic. So it's Joel Thorstensson, and it's Ceramic talking about open sourcing the world's information with programmable streams. And then last but not least, we'll have Michael, and he'll be talking about DIDs and IDX, a cross-platform identity system on IPFS. So welcome to all of our speakers. Welcome to everyone who is joining. There are people. There's 444 people. Okay, no, not that many, but there's nearly 50 people here today, and probably loads more that are going to watch this on YouTube. So so no pressure. But welcome everyone. It's really nice to see you. Really nice that people are coming to these events. And let's get started. So first up, we have the Scala Project and how to secure a blockchain using IPFS. The Scala Project, would you like to share your screen and begin?
Yes, absolutely. All right. All right, can you see my screen?
Yes, I see it.
All good. All right, so hi everyone. I'm Mastermind, which is obviously not my real name. Well, I'm an application developer at Scala. I'm with Hezam, also a developer, a blockchain developer, and Donovan. Both are developer at Scala. We are very excited to be with you today to present our project and how we use IPFS technologies within our ecosystem. The presentation will take place in three parts. First, Donovan will introduce our libIPFS library, which allows us to use IPFS within our applications. Then Hezam will present in a concrete way how we are planning to use IPFS to secure our blockchain against potential attacks. And finally, I will present some other uses of IPFS within our project. But first of all, let me introduce Scala and who we are and what we do. So our first goal is to keep privacy as a priority in everything we do. This is why we forked from Monero in the first place and provide an opaque blockchain, untraceable payments, unlinkable transactions, and blockchain analysis resistance. Our vision is to distribute wealth for everyone and every device. We want to be the people's coin. And to achieve this goal, we focus on implementing solutions that are mobile friendly and very energy efficient. There are about 4 billion mobile devices in the world, and we want to make sure that our ecosystem takes that into account. We also take a lot of time to improve the user experience so that our applications can be used easily by anyone. And finally, one of our goals is to solve real-world problems, obviously, in a way that is economically viable for the project and to sustain our growth. So now I'm gonna let Donovan for the next part.
Yes, thank you for that. One of the goals of our project has always been to be as decentralized as we can possibly make it. We don't ever want to get into a position where we're called the central authority of the chain, where we can manipulate things. And when we started looking at ways of securing our blockchain, we knew that IPFS would really align with that vision. And I believe that has led us to become one of the first projects that's using IPFS in a way that can actually impact the consensus of the blockchain in the way that Haizam will be explaining it in the next section. Another goal of our project, like it was just mentioned, was to have ease of use. We want to make it as simple as possible for anyone to get involved. And for that reason, we knew that our IPFS integration needs to be part of our core package and not require any additional dependencies to be installed or any additional downloads and registrations all over the place. So with that in mind, we explored our options. Our main daemon that runs on client computers, on servers with exchanges, that's built in C and C++. However, IPFS is written in Go. And at the time we started looking at this, which was probably more than a year ago now, there were no implementations to use IPFS directly from C++ without having a standalone IPFS running and using HTTP APIs. So one of the good things with Go is obviously that you can link Go libraries into C++ code, and that made it really a possibility for us to take IPFS and pull it into our main daemon, and from there libIPFS, as we call it, was born. Our initial integration with IPFS was quite low level, if I could call it that. Our library would set up, initialize, and run IPFS from within our own Go code. What I mean by that is we use a lot of the startup logic that you can find in the standard IPFS daemon itself, and we ran that inside of our library. What was great about that is it allows us a great degree of control of what we start and what we don't start. We disabled at the beginning the HTTP API because we didn't need it. The other reason for that is cryptocurrency exchanges typically don't want anything other than the core network tools, because they don't want the overhead, especially the smaller exchanges that don't really have a Binance kind of setup to operate these chains on. So the other great thing about integrating on that level was that we could expose different IPFS features directly to our daemon by wrapping that feature inside of a simple C++ to Go call. And the first version of this test was done in the 4th major revision of our software. That was about probably a year and a half ago. And that fetched some of the seed nodes and some of the core network data that it needs to start up from IPFS. And to our surprise, almost no issues, apart from some users that ran a very restrictive network setup. Some of those calls were blocked, but other than that, it really worked really well. Fast forward a few months later, we reviewed our integration, and we found that dependency management in the long run is going to be really tricky. This was a time when Go was in that awkward space of not really having an official dependency management system like it does now with Go modules. Some projects were using Go vendor. I believe IPFS had GX, and some other ones just had none to speak of. And it became obvious that because we had such a low level integration, that any changes in the IPFS core would disproportionately impact our integration, which obviously takes time away from our main focus being the cryptocurrency. So to overcome this, we recently took a bit of a higher level approach. We still need the Go wrapper around IPFS so that we can start the daemon from C++. But instead of doing all the work, initializing the network and connecting and all of that, we package a compiled IPFS binary and embed that inside of our library with a tool named Escape or ESC. And when the daemon starts up, it calls a function, it extracts that package, starts the IPFS daemon, and we can communicate then using the HTTP API, which works perfectly fine. What's nice about this approach, again, is we can add command line flags to our C++ code to disable that functionality for exchanges, which keeps them happy. We still achieve the goal of not having additional software to be installed by our users, and we get a win out of that so that we don't need to worry about dependencies, and we can just take advantage of all the new IPFS functionality as it becomes available by just repackaging that binary into our code. So that's an overview of how we do this on a low level, and I'll pass on to Hazem now, which will explain how all of this comes together to really secure our blockchain.
Hello. Am I right? No. Hello, everyone. Hope you're all doing well. I'm going to start by actually proposing a question. Why do we need additional security for the blockchain? Is it not supposed to be like inherently secure without the for any third-party applications or implementations? I'd say it's a pretty difficult question to answer. But it's not a necessity for a coin like Bitcoin or something like that, because they have a lot of miners and nodes and all that stuff to ward off most of the common attacks. Our problem is pretty niche, and our solution is quite niche too, mostly applicable to projects that don't enjoy the same level of decentralization such as that of Bitcoin. So before we jump into how we are aiming to solve the problem, let's take a look at some common network level attacks against the blockchain in particular. Distributed denial of service attacks. They are pretty common on blockchain these days. Since if you're a small project, especially with not a lot of peers hosting your chain, it's pretty easy to take out the nodes that are good to cause a lot of havoc. And the next type of attack I would say is cyber attacks. And recently Monero had this very specific attack for a bunch of nodes pretended to be honest and try to find origins of certain transactions, which was pretty complex, and at the end was able to cause a lot of problems too. Now, moving to the main kind of attack that causes the most amount of problems in the industry is 51%. And if a dishonest peer has enough compute to overpower the majority of the network, they would be able to rewrite histories, basically. Mostly to spend the same amount of coin multiple times. I'm sure you've all heard about this issue before. This can be devastating, especially for medium to small size projects, and it could cause huge amounts of losses for exchanges and such. And there are quite a lot of existing methods that work towards protecting the blockchain against attacks, specifically 51% attacks. And we'll take a look at two of them in brief. One of the best in the market, which a lot of coins actively use, is delayed proof of work by Komodo. It's actually pretty smart as well. They use the Bitcoin's blockchain to store arbitrary data, in this case, block hashes of a network that Komodo is trying to protect. And it is regarded as one of the go-to solutions for a lot of projects at the moment, especially popular ones like Ninja Square or Pirate Chain use delayed proof of work for security. And another solution that is also pretty popular in recent times is just good old aggressive checkpoints, where basically they just don't allow any kind of reorganizations past end blocks in the past. This actually could cause a lot of issues, as they already had in mind, but there is no other option to protect against it. It could devastate the chain. So now that we've taken a look at some of the existing solutions, let's take a look at our solution, which is called DRD. And in essence, it works a lot like KMD's delayed proof of work, but instead of using the Bitcoin's blockchain to store arbitrary data, we use IPFS, since it's a lot cheaper, faster, and more reliable. And even though Bitcoin has a lot of compute and security behind it, it is still vulnerable to 51% attacks. So if somebody has a lot of compute, they can overpower the chain and then take majority and rewrite history there. So in DRD, there are essentially certain nodes that consistently take block hashes, which are blocks in the network, and then publishes those block hashes along with the height and some other parameters onto IPFS and then IPNS, so that the client blockchain daemons can resolve it and get the checkpoint and then add it to their local databases. And then the way we pick these node maintainers is by a yearly election. That this gives people a chance to be a part of this second layer network, and it also decentralizes some of the power that these nodes have, because they have a lot of power, come to think of. And they're also incentivized with tokens from the network, so they don't have an incentive to cyber attack us. And then about 25% of the block rewards right now goes to node maintainers on our network. So essentially, this is a solution in very, very simple terms. And I've actually written a simple web application to show this in action. Just a side note, right now we're in private beta, looking to move to public in the next few weeks. And I think Mastermind could show the demo there. Yep, this is the thing I was talking about. So basically, you can see 3 nodes here. They are taking block hashes from Scala's blockchain right now, and then adding that to IPFS so that other nodes in the network could fetch these hashes from here and add it as a permanent block, so that there cannot be a reorganization past this block. And it's pretty cool. And I should say the latest update, 0.8, it is really fast. I mean, like IPNS resolutions used to take like 2-3 minutes at most. Now it takes like 10-15 seconds at most, and it's really cool because it avoids a lot of DDoS attacks and all that stuff. So yeah, I'll give back control over to Mastermind, and thanks for the opportunity, and hope you all have a nice day ahead.
Right, thank you, Azam. So I will now introduce, to conclude our presentation, some other users of IPFS in our project. First, our official website is hosted on IPFS, which makes it decentralized, scalable, and less expensive to maintain. You can access it at scalaproject.io if you want more information about that, about what we build. In addition, we have also developed a proof of work algorithm that makes mining on mobile devices possible. So we have recently released Scala Miner, which is a mobile application that allows mining on any Android device. The application provides a detailed dashboard to track all the mining activities, as well as 2 layers of temperature control to protect your device from overheating. We use IPNS DNS link address using IPFS gateways to fetch the list of mining pools, which ensures maximum service availability. And you can download the application at mobileminer.scalaproject.io. And finally, we are currently working on Phantom, which is in development. It's a content delivery, distributed content delivery network, a CDN. It's gonna allow us to offer our users a secure and decentralized file hosting, leveraging our IPFS notary nodes, and obviously our mobile ecosystem. So that's it for Scala. If you have any questions, feel free to ask them at the end of the meetup. Thank you, everyone.
Thank you, guys. That was brilliant. That was very cool. Cool. You are just about on time. That's fantastic work. Good job. Just a reminder, if you have any questions, then please put them in the chat. We'll try and fit them in when we can. Yeah, if there's no questions so far, then please, I guess, feel free to get in touch with the Scala Project at scalaproject.io. Is there a different place to, or is that the best place to contact you guys for questions and things outside of the meeting? I guess Oh, well. All right. Well, let's move on then. So next up, let's just have a look at where we are in the schedule. Okay, so we have had the Scala project. We now have Daniel Buchner, and we have Ion V1 launch and a look beyond. Please, Daniel, take it away.
All right, everyone can see it? Oops, one slide.
I see it.
All right, so today we're going to talk about Ion. It's this decentralized identifier implementation. Runs on Bitcoin, but importantly for this discussion in this group is the fact that within the implementation, the file transfer and replication protocol it relies on is IPFS. So we'll talk a little bit about that, how that works, as well as identity and Ion in general. Maybe you want to get involved. So first question to answer is, what is identity, right? So it's sort of a notoriously difficult thing to define, but I want to give a definition that I think should cover it all because it's everything. Identity is everything around you, right? Like literally everything other than money, probably you could argue, in the sense that it's everything you say, do, think, experience, express, your political views, your app data, like anything in the world that could define you as a person is your identity. So it's really, really important that we create a system that is both secure and decentralized, because, you know, this is really like the story of your life, right? So why is identity a must-win fight? I would argue it is a must-win fight because if you define identity as the thing that grounds all of these activities, you know, your social media, you know, your communications with others, all of the stuff you type into the digital sphere, which is like, you know, my grocery lists, my thoughts and feelings and documents, like this is incredibly sensitive data. And if we don't win the fight of identity, the thing that gates access to that data by outside parties and gives them the ability to read it or not, I think we're in for like maybe not such a good future. So explaining the root of identity, right? What we're talking about today, Ion, is primarily the bottom of this tree. It's the foundation of identity, not identity data. So one thing to really keep an understanding of in your mind is that identifiers are very different than identity, right? Identity is the sum total of you. Identifiers are references to all or part of you. And so when we talk about what is an identifier, you all use them, you know, email addresses, usernames, these are all identifiers, but they're centralized. So people can take them from you, right? If they want to. If you're acting naughty on a social media website, or naughty as they think you're acting, they'll take your account away. You lose all your connections, all the content that you had is gone, right? It's not really yours. They're leasing it to you. Same thing with email addresses. You can be erased. You can be depersoned. Now your identity data is all the stuff that actually defines you. Your identifier is just a reference point. So an identifier doesn't really tell a whole lot, right? I mean, maybe if you put your name as your email address, as most people do, it obviously tells something, but a big random identifier doesn't actually tell you about what it identifies. It could identify a person. It could identify machines. So without identity data, identifiers are just pseudonymous IDs backed by strong cryptography. And we'll talk a little bit about what decentralized identifiers specifically as a type of ID are. Decentralized identifiers is a W3C emerging standard that just went into candidate recommendation just 2 weeks ago. And it's going to be an international standard. It essentially sets forth a standard for a URI scheme and a data model for the expression of keys and endpoints in relation to an identifier. And what Ion is a formulation of DIDs. It's a implementation of those standards. Over on the right, you'll see, you know, one identifier, an Ion identifier. It's not friendly looking. It's not like an email address. It's a 32-bit string, a 32-byte string, and it maps to this DID document, which is a JSON document that contains some public keys that you might associate with your identifier and some service endpoints where people might be able to go find identity data. And those are really the two most important things that link to a DID. The big difference here, obviously, is cryptographically secure, and these IDs are yours. They can't be taken from you. They have all the value of Bitcoin and all of those attributes, in the sense that, you know, it's as hard to steal someone's well-secured Bitcoin keys as it is their identity as it is their Bitcoin keys. So let's talk about ION. What is it? It's an open, public, permissionless layer 2 network that runs on top of Bitcoin and enables one implementation of decentralized identifiers at pretty awesome scale. So doesn't rely on any of the things that you may see in other protocols. There are no central authorities, you know, strange coming from Microsoft, obviously, but there's no signatories, there's no cabal, it's not Libra, there's no CEO, right? Just like the CEO of Bitcoin is not, you know, been called in front of Congress, you're not going to find the CEO of ION there soon either. So how does it work, right? This will get into a little bit about IPFS. So in ION node, anyone can run them. Basically, inside of an ION node resides Bitcoin, some processing logic module, and for this group, an IPFS node. Every single ION node runs an IPFS node. We use Go IPFS. And what that actually allows for is all the nodes to ensure that they circulate all the specific data that they know they should have. And how do they know they should have the data? Well, they're watching Bitcoin for embedded IPFS CIDs that are placed into transactions. And if those transactions, you know, pass a certain set of deterministic rules, they ingest the CID and they start looking for that data. And essentially, the system's a really, really big CRDT. It's basically an authenticated CRDT that uses Bitcoin as a clock. And as it pulls all the data in from all the IPFS CIDs of the anchored batches of DID operations, it compiles them in a deterministic manner that is not subjective in any way. It's formally and mathematically provable. And there's no one that can stand in between you and that consensus, because the consensus is purely math. So that's kind of the big role IPFS plays. And it's interesting in the sense that ION nodes do not speak to each other than through IPFS. They watch each other's transactions in Bitcoin, and they communicate over the IPFS protocol to make sure that they circulate and replicate the mirrored set of data that makes up ION. So what does ION deliver? Well, like I said, it operates at massive scale, you know, thousands to tens of thousands of operations per second. It's really efficient. People say, you know, they ask us all the time, especially folks that aren't really familiar with these sorts of technologies internally. Well, but Bitcoin's so expensive. It's just so expensive for transactions. Well, maybe, right? I mean, if you were to write cat pictures into Bitcoin, you got to really care about that cat picture for $5 a pop. But if you're writing, you know, say 10,000 DID operations that can be embedded through one Bitcoin transaction, even if the price of Bitcoin went to $100 per transaction, I mean, that's 1 cent per operation. And an operation could, you know, be grounding the ID of, you know, Jeff Bezos's ID. Do you think he's willing to pay a penny? I do. I mean, they'll charge you, you know, $1 when you switch out your SIM card, right? It's all kind of bundled up in your contract. So for switching out a single SIM every few years, when you get a new phone, you can pay for all your ID ops, probably for years at a time. So we think it's a pretty good deal. ION also includes a light node configuration, so that you only need to actually have on hand at any moment as a light node about 5% of the total data set in the world. To give you a picture of how much data that would be, for under 2 terabytes of storage, you could anchor 50 billion. You could have 50 billion active DIDs in the PKI system. So basically onboarding the entire planet to ION, we could spin that at about 1.8 terabytes, which is pretty good. Decentralized registry. So ION, unlike some other methods that are completely where there's no index, right? Some other methods are essentially like you can call into some specific prover module and figure out your IDs, keys, and endpoints if you know the ID, but you can't see all the ID strings. You can't see, like, you know, ID 1, 2, 3, 4, 5, 6, all the other ones, right? ION is specifically enabling this through a decentralized index. So every ID that's anchored in ION, you could at least know its ID and its keys and its endpoints. Now, you don't know who it is, so it's not giving you a huge, you know, vector in terms of like actual identity data, but there's some really cool things you can do with that. One is you can type IDs. So I could create IDs that have certain types that are, you know, digital things. They're, you know, types that span from people to machines, all sorts of things. And then you could basically parse the global substrate of IDs and, you know, get whatever batch of those IDs of whatever type you want and create your own registry for those things. We'll touch on that a little bit in a sec. So, little roadmap. We talked about, you know, how ION's getting to V1. It's been a while. We spent about a year just kind of thinking about how best to approach the space, did some just conceptual work. In 2019, we had a draft of the underlying protocol Sidetree, which is blockchain agnostic. There's people running it on Ethereum as Element and others. That's actually just been standardized by DIF. It is now an official DIF ratified standard. We got a beta running of ION, the specific implementation of Sidetree anchored in Bitcoin in 2020. And we ran that beta for about the duration of 2020. And now in approximately, don't hold me to it, but I think Thursday, we are going to V1 production, Microsoft GA with our node. And we can't speak for anyone else because obviously the protocol doesn't just hinge on us at all. But we are confident the spec is in good shape. The underlying protocol has been standardized and it's going to be rolled out just like any other production service for us anyway. So more information will be coming to you in the coming days. And quarter four 2021, we want to integrate it certainly in all of our identity products as a company. You'll see auth modules coming out, people being able to log in with DIDs and all sorts of things that we think are just really cool and enabling for the community, the decentralized community in general. So what's next? After DIDs, there's another place that IPFS can play a really, really big role. And I think some other folks, in the conversations to come will touch on this. The next thing is personal data stores. So, what's an ID worth if you can't connect to some data and maybe ask for some stuff of someone's to learn about them or something they want you to hear about? The concept here is that in those service endpoints that you can associate with your IDs, you might want like a personal data store endpoint where you can put some public data, maybe you could put some encrypted data and maybe data that's encrypted for multiple parties, a whole mix of types of data. And for public data, it might be something like Blue Sky, like maybe your tweets live in your personal data store. So that if I wanted to go get the tweet of say Bob, his list of latest tweets, I would look his DID up, I would find his service endpoint, and I would go to a standardized personal data store and ask for that type of object. The Ceramic folks are on later, they've done a really good job of this public data piece, especially. And if I have that, I can start building decentralized applications because I can actually go and get the data in a known universal way from my peers. And so there's a whole lot of power in that. And that's I'd actually argue that's the most powerful thing about decentralized identities when you pair it with these data stores. So we believe that DIDs really are the DApp platform. There's no decentralized identity itself was always the platform. I just think people are waking up to this now. Why do I need Signal and Telegram when I have DIDs with keys and standardized personal data store endpoints? I have an implicit, universal, worldwide encrypted messaging service that's a standard. It's a little bit better. I'd love to deprecate those companies. In fact, that's probably what we're going to try and do. Social media. Why do I need people telling me that I'm kicked off their platform when I have my own DID and that's what people follow? And I don't need them in the middle and they're irrelevant. What about the gig economy? If I'm in Austin, Texas, and they say, well, you can't operate here, Uber. Well, what if the way that drivers and passengers start talking to each other is through DIDs and personal data stores? It makes the interdiction barrier down to the person. And that's exactly where it should be, so that they don't have as easy a time inflicting roadblocks on people trying to exchange in buying and selling of activities. So same thing about content registries. The Apple App Store, really, what is a registry other than identifiers linking to things, right? We own NPM, Microsoft, and heaven forbid something happened to that SQL database, right? That connects the world's code to identifiers that you type into your package.json. We think there could be a better world. We think that maybe you have DIDs that stand for your packages and you crawl ION and find them all. And you can have like a global registry of code that can't be, hurt by anyone, even us, the owners of NPM. So maybe I'm just going to posit to you that could it be that decentralized identity is actually the app platform that people haven't been enamored with because it's not as sexy. It doesn't make you money. You can't ICO it. You can't shitcoin it. It doesn't just turn billions in your pocket overnight. But it is real. It's serious. And some of the largest companies in the world are recognizing the value of it for their own reasons. And I think you should maybe look into it too. So that's my presentation for now, and happy to take questions at the end of the talk. Thank you.
Thank you, Daniel. We've got a couple of questions in the chat. Seeing as we're right on time, just quickly, so this is from me actually. Is there some aspect of Bitcoin that Ion specifically needs, or could it potentially use a different blockchain?
Yeah, so PKI in general, there's one problem with PKI, and it's been the same problem for a long time. Satoshi actually solved something that wasn't the double spend. The first most basic thing that blockchains solve is linear sequencing of events. We've actually never had that ability ever before. We've never actually been able to say in definitive and non-relativistic time, this thing happened before this thing. I mean, it sounds kind of crazy, right? But that's actually what you need with PKI, because when you create an ID and you say, well, here's my ID, and it has one key. If you go get another phone, you want to swap that key out, you have to know that this happened before this, because eventually you're going to have a lineage. And if anyone can sort of branch off that and you don't know what happened in what order, that's actually what Ion uses Bitcoin for. It's just a clock. It just anchors things in a sequence. So we could use any, yeah, I don't think you can do that without a blockchain. So someone asked that. I would love to see a decentralized clock implementation that someone's done that is immutable and that you can't replay, that absolutely has one source of truth. We call it the chronological oracle problem. It'd be great to see that, because then you don't need a blockchain, and apparently double spend is solved through a different way, which we would love. I think everyone would love to see.
Nice, thank you. And so how is chain anchoring implemented? It sounds like a in-depth question. Do you have like a 30-second
answer? Yeah, absolutely. So it writes it into op-return transactions. It's about 40 bytes that it writes in there, and it's prefixed as leading bytes. And there is actually an escrow scheme that's part of it. If you wanted to write larger batches into Ion, you do have to escrow a sizable amount of Bitcoin, lock it away in a time lock so that we know you're depriving yourself of value to be able to access larger volumes.
Nice. Okay, thank you. And oh, okay, so Victor says, are you planning to run on something other than Bitcoin?
Yeah, so Sidetree, which is the agnostic protocol that underlies Bitcoin, which we use on top of Bitcoin to produce Ion, is fully able to be implemented on other substrates. There's, for instance, Elements is the implementation of Sidetree on Ethereum. So you could apply it to the blockchains. We just chose the strongest, most irreversible one that we could.
All right, thank you. I think we need to move on now. Thank you very much, Daniel. That was awesome. So let's have a look. Where are we? Oh, here we go. We just heard from Daniel with Ion, and so now we've got Joel talking about open sourcing the world's information with programmable streams. Joel, would you like to take it away?
Yep. All right. Awesome. Let's see if I can find my screen. Okay. Hi, everyone. I'm Joel, and I'm a co-founder of 3Box Labs. Today, I'm going to be talking about Ceramic and how we see it open sourcing the world's information, and kind of diving into what we mean by programmable streams and how it all relates to identity. Cool. So what is a world of open source information like? What would that look like? So we think that we really need to de-silo all information in the world, or like a lot of information needs to be de-siloed. So how can we share information like across organizational or application boundaries? And it seems like this kind of system needs to really be based on public key cryptography, like Daniel kind of mentioned a bunch already. We see that this can be achieved with stateful streams. And what this really means is streams of events and then processing on top of that. So we get a state. And in Ceramic, what this looks like is that we have individual streams that are separate from each other. So you don't have to like compute like a global state of the entire network. And yeah, so this is kind of a minimal building block for interoperable information. And if we have this, we can kind of create a global data environment where we can share these streams globally. The commits or the events of the logs of the streams can, though, originate locally. So I create on my machine, and it's like propagated throughout the network. And ideally, we'll also have like multiple different data structures that are supported. And I'll kind of get into that a little bit more soon. So the goals of Ceramic is really to facilitate this in a scalable way. So basically, we want to be able to handle the world's mutable information. And obviously, it would be preferable if this is quite low latency. We want it to be flexible. So if we want to be able to support like a bunch of different types of information, we can't really just like have one data structure and like one state representation. It needs to be like support for various different formats and types of data and streams, and yeah, different ways to represent the state as well. And if you look at a blockchain right now, like they have global state, which means that you kind of have one big state machine and everything needs to happen within that state. And that's kind of cool in kind of the world of financial stuff. You can do flash loans and things like that, which is kind of totally mind-blowing. But if we're working with like information, we don't really need that kind of composability of messaging in the same way all the time. So we want to be able to have like local consensus of these different streams independently of each other. So we don't need to like coordinate everything together at once. So yeah, so we would use consensus by stream, and potentially they can also make this work offline. Yeah, so this is kind of the goals of Ceramic. So where we're at right now. So we have a public network that is kind of global. Has these local per stream consensus, and we're really working on right now is like making the mainnet, making that go live, and kind of then focusing on like scaling out this and like allowing more different types of stream processing stuff. All right, so let's dive into like what is a stream and why is that? What do we want to do with it? So we call them. We like to refer to them as like a stream of commits, and essentially this you can think of each commit as an event which is signed, or it can also be like verifiable in some other way, like a blockchain anchor. But essentially, it's a commit that contains some kind of data that allows you to update the state of the state that the stream represents. We give each of these streams like a unique identifier. I'm going to refer to them as stream IDs. Currently, in the Ceramic implementation, they're called document IDs. But streams, since we're using the streams language, it's more appropriate. And in theory, these commit streams can be like any type of IPLD data structure. So like any type of IPLD DAG. So it could be used to represent like DAGs, or just like straight, append-only logs. Currently in the Ceramic implementation, we have like one log, so there's no like branching supported yet. That's something that we'll add in the future. And yeah, each stream is processed independently, so you can kind of parallelize this quite well. Yeah, and here to the right, we have an example of like a Genesis commit, which is like the first creation of the stream, and then like an anchor commit anchors it into like a blockchain, and then signature commits contains like patches or other types of modifications or like other types of like data events. And then there's stream processors, and these really governs how the state progresses as there are new commits or events that come in. And they define what is a valid commit, and they also define like consensus rules if there's like divergence or different opposing views, like what's valid, like is the signature from a DAD that's like allowed to make the update or not. And finally, to like make this really work well, especially in an environment where we have the IDs, and we need to have this kind of secure key rotation that Daniel talked about. We use checkpointing, and really this could be done in various different ways. Right now we anchor periodically into Ethereum, and these anchors can be batched. We can like take updates from a bunch of different streams and anchor them into Ethereum with like one transaction. But in theory, you can do it in other blockchains or potentially using some kind of committee. So Ceramic is a completely decentralized network where a Ceramic node is based on IPFS and Ethereum. So IPFS and IP Elite store kind of the commits in the stream, and Ethereum to do the anchoring. Then we use libp2p to gossip the tips of the stream. So the tips basically mean what's the latest update. And I can also make queries for like, hey, I have this stream ID. Like, how can you give me the latest update? And I can verify just an individual stream locally. I don't need to care about the whole state of the entire network. So we can make extremely light clients. But we have a global namespace, and each stream ID is global. So I can look that up from anywhere. Streams can depend on other streams. So I'm gonna, in an example later, talk about we can have schemas that are enforced on some streams as they apply updates. We can also have links between streams, so they can link each other in the state. So we can like kind of start creating a graph of information once these streams are being processed. And finally, like, how do we persist the state of the logs, like these logs that keep growing, like how are they backed up? So you have like a bunch of different options, like you can store this log in S3, or you can store it on a remote IPFS node. Obviously it's stored on the local Ceramic IPFS node, or you can back it up to Filecoin or some other kind of data persistence network. So in Ceramic, we have this concept of stream processors, or doc types, as they're currently called in the implementation. There's two doc types that are supported right now, but you can kind of implement your own custom. So tiles is just a JSON document that optionally has this JSON schema enforcement that I talked about before. So the JSON schema can live in another tile and then be enforced once you update the tile. And the conflict resolution we use here for tiles is if there are two separate branches of the tile commit log, which we saw up here. So there are two branches of this log. What essentially happens is the one branch that was like anchored earliest is the branch that will be the canonical branch. And this also makes it possible to do secure key revocation. The type 10 link is interesting because in different blockchain systems, so like Ethereum, Filecoin, and Polkadot, and like Cosmos, you have blockchain accounts, but they're not really the IDs. But with a type 10 link, we allow you to like link a blockchain account to a DID, and this can be like cryptographically proven, and it's pretty cool. It works quite nicely to just tie together the whole blockchain ecosystem into like this DID ecosystem. And yeah, you can create any type of custom doc type. Right now, you're limited to this earliest anchor wins conflict resolution. But yeah, in the future, we hope to like make that into a more broad conflict resolution strategy where you can use things like CRDTs and stuff like that to enable this to be used in a more kind of better, basically get a better user experience out of the system. Right, so let's dive into identity on Ceramic. So the IDs is the account model of Ceramic. So in tiles and like the main way you can access like the public and like request signatures from a user in the Ceramic when you're creating doc types or when you're using tiles is the IDs. And to facilitate this, to request signatures and decryption and stuff from the wallet, we have defined EIP 2844, which is a way to like interact with the wallet, request signatures, request this decryption. And Ceramic is really DID agnostic. So like any DAD method that conforms to the standard, plus minus like some specifics of, so you can use DADs in a trustless manner. And we have some DAD methods that are right now natively supported. KeyDid is one of them. It's like the most simple DAD that's just like a public key pair. 380 is a DAD method that's built on Ceramic using ceramic tiles. So it's just like basically putting a DID document into a ceramic tile. Recently, we started working on something called NFT DID, and that's kind of cool. You can build basically an identity that where the owner of the NFT is the one who has access to write and read stuff. So you can basically have this transferable or tradable identity, which is quite neat. And we're also working with some teams to add support for org identities. So like that's on-chain DAOs or organizations. So like Gnosis Safe and Moloch DAO to give those types of organizations DADs. And yeah, just quickly, the way we represent signatures in commits is using a standard called DAG-Jose, which is like a standard for signed encrypted JSON objects. Works quite nicely with DADs. And in the future, there could be potentially other signed data formats that work nicely with DADs as well. But DAG-Jose works pretty well for now and is standardized within IPFS, and Jose is standardized within IETF. All right, so what are some use cases, especially like as they relate to identity? So publishing, you can publish stuff and they will get, you get that persistence of like things being anchored on chains. You get this proof of publication, which is useful for like scientific publishing, journalism. Commenting is interesting because like a lot of DAOs, especially in the blockchain ecosystem, really want to be able to make comments and know that they were made by the right person at the specific time, so they can reason about the governance process. And related to that, off-chain voting is also like an application that we have been exploring a bunch. So doing stuff like conviction voting and quadratic voting. Quadratic voting, it's really important to have like some kind of sense of strong identity or like identity reputation, which kind of ties neatly into the next thing, which is identity index. And I don't think I really have time to go into that, but Michael is talking about that in his talk right after this. And just because like Ceramic is based on these streams that you have some processing on, you can imagine like a bunch of different applications based on this, like potentially like service orchestrations, have some kind of global event logs for things that are going on in different areas of the world potentially, or yeah, analytics. Like it's really kind of a lot of stuff that you could potentially build on it. All right, so Ceramic is currently in the testnet phase, but we have an early launch program. So if you want to check it out and try to build on it and be one of the first people to be on the mainnet, you should check out the early launch program. And yeah, check out our documentation for like diving in and trying to build cool stuff on Ceramic. All right, thanks all for listening.
Awesome, thank you. That's rad. So it doesn't look like we've got any. We've just got a question. Do you still accept project applications?
Sure. Yeah, the early launch program is open.
Okay, rad. Okay, all right. We are low on time, so we're going to skip straight ahead to. We're not going to skip anything. We're going to go straight ahead and let's have a look. We have got DRDs and IDX. This is Michael. Michael, would you like to take it away for the last talk of the night or morning, wherever you are?
Afternoon. Sure. You can see my screen, right? No, not yet.
I can see your face.
That's half as good.
Okay, I see your screen now. Thank you.
All right, great. I will try to shorten this a bit because we're low on time. But yeah, so IDX is a cross-protocol identity standard. Tying into the previous talks by Daniel and Joel, IDX, which we'll dive into, is really a way to manage the entire universe of user information or just generally information about a DID in a decentralized way. And it's built on top of Ceramic. So it has all the properties that Joel just described and uses Ceramic tiles and other stream processing data types to basically create the system. And all right, so for fear of repetition here, I won't go into detail about all of these things, but sort of building on what Daniel said, identity is really the aggregation of information about a subject. So the entire universe of all the things you say, do, your presence online. And in Web 2, obviously we have app-specific identifiers that require, server-side authentication. And in a traditional, relational database model, if you're using DynamoDB or something, you'll probably, build a user table. Except these are all just fragmented and app siloed. So they can really only map to other data resources produced by the user as they interact with that single application. And they're not designed for interoperability. So they're tied to the one tech stack implementation that application chooses, and they actively discourage discoverability of this information by outsiders. They keep it safeguarded because that's their business. But in Web 3, it sort of aims to flip that model from app siloed to user siloed. And the pieces of that are open identifiers, so DIDs, like Daniel and Joel talked about, with sort of client-side authentication. It could be server-side, but sort of client-side as the starting point for decentralization. And ideally, you have this unified DID-centric index of information and resources associated to that user or that identity. Ideally, this index maps to resources anywhere because there are different data producers and consumers. So as a user interacts with app A might be storing data directly in Filecoin, or app B might be storing data in Textile, app C might be storing data on a centralized data store somewhere. And the aim is to make all of that data interoperable and discoverable in a single place, a unified location, independent from any technology that any single application implements. And I won't have to go through this, so thanks, Daniel, but the building block is DIDs. Really critical to sort of understand that these are decentralized identifiers registered in some decentralized, ledger or data platform where this data is independent of any third party. And these identifiers and their resulting documents that they represent are truly decentralized because everything sort of builds from that. And so if we think about, the design goals of really what one wants to achieve when designing a decentralized identity standard, we can see them on the list here. And so the first one is really just flexibility, sort of making the standard agnostic to any particular technology stack that a given application developer might choose to deploy on. So it's ideal that this standard works with any DID method, whether it's Ion, being run by Microsoft, or Element, the other implementation of SideTree, or 3ID DID and some other DIDs native to Ceramic. Like, it shouldn't matter because these DIDs will come from all over the place. It should work with all authentication methods and key pairs. So, being able to control one identity from n number of sign-in methods, whether that's a blockchain key pair in a client-side wallet or a social login managed by a service on a server, those should all be able to control the root identifier, which from that you generate, the signatures and the encryption, which enables attribution of content and control of information. And it should work with all data storage technologies, formats, and locations. So whatever you want to build on, wherever you want to deploy, it shouldn't matter. Discoverability. So this is really the key piece to building sort of this data index, where instead of the app siloed model where we have today, moving towards a user siloed or user-centric model, it's important that we begin to describe data semantically versus describing it like, oh, it's data from app A or data from app B, because app C might not care or know that, app A and B are both blogging platforms. And so I need to know which other apps a user has used when I'm querying this information, it should be described by the data itself, like by the shape of the data, the schema, some metadata and description, so that it's more interoperable. It's not tied. You don't need to know all of the other apps that are also using the standard in order to consume data that wasn't created by your application. And this should all be organized in one logically centralized location. And it's logically centralized because it exists in one place, but it's on a decentralized network. So it's, you know, sort of physically decentralized, but logically centralized. And it should be privacy preserving. So this system should be able to support public and private information, as Daniel mentioned. And really the concept of pseudonymity and progressive identity needs to be prevalent when designing it. You can't build an identity standard that has a requirement for like a meat space ID or like a government issued legal identity to use and onboard, but rather all identities sort of start pseudonymous and empty. And depending on what sort of information the user adds to them as they interact with apps, this identity begins to gain meaning over time as it's used. And it's up to the user to decide what sort of information they want to add to this identity. Some of them could end up taking on the shape of legal identities. Maybe that same user has a different identity that they begin to form into a different sort of like persona. You know, we're not limiting one user to one IDX, but rather sort of keeping it open so it can be used in as many ways as desirable. And it's important that these have standard interfaces. So, you know, a common way to read and write information from this index makes things interoperable. You don't have to integrate one-off APIs for every single data source because that would be too cumbersome to actually achieve our goals of interoperability. And, you know, trustless and scalable. So deployed on decentralized permissionless infrastructure in the same way that Daniel said DIDs themselves should be. Well, also this index IDX data structure should be sort of as the first principle, because then it's truly controlled by the users and not by a third party or a server that if it goes down, all of your data and routing information is now gone, even if it's for a period of minutes. And scalability. So the infrastructure, the decentralized infrastructure it's built on needs to be able to scale to be able to support it, which is sort of why we deployed IDX on Ceramic. And a quick intro to how it actually works. So it's a decentralized data structure using Ceramic streams for associating any kind of data to a DID. So here you see DID1 happens to be a 3ID, which is a DID method native to Ceramic. It uses a tile, as Joel said. And here on the bottom, you see DID2. It's an ION DID, so it's, you know, anchored in Bitcoin on the ION protocol and network. And they both have a corresponding index. And even though the DID documents that Daniel talked about, he showed they have public keys used for signature verification and encryption, and also additionally service endpoints. The nice thing about Ceramic and IDX is you don't actually have to register the index in the DID document as a service. You could for redundancy, but Ceramic has this deterministic property where if you know the DID and you know you're looking for its index, you can deterministically query for this index and the Ceramic protocol will resolve and return the index for the user without needing to actually establish a link, which is critical because there's so many different DID methods. Having like a common way to plug them in might not always be feasible. So given a DID, you can always deterministically generate what its index is and return the current state. And here you see two users. And so next, a developer will create a schema, publish that to Ceramic in a tile, and we'll take that Ceramic stream ID and plug it into a definition and then deploy that definition on Ceramic as a tile. And a definition basically is the semantic description of a resource. And so here you see some metadata. Let's assume that it's a basic profile. It has some description, a universal profile, and it has a schema. And so this serves the stream ID of this definition serves as a key in the index. And as a developer, I only need to create a definition once, and I can use it for n number of users. So in user 1 on the top and user 2 on the bottom, that same stream ID will both of their indexes. And now as a user 1 comes to my app, they plug in some profile information. It happens to be Satoshi. They have an IPFS image and they have a description. And at that point, using the IDX API, when you create this record, it the IDX library automatically publishes the definition stream ID and the record stream ID, which is a separate stream, into your index. So now you have this map from stream ID of definition to stream ID of record. So you have information stored, semantically organized. And now when user 2 comes, the same definition stream ID is a key in their index, and they create a separate record, which is its own stream, which contains their profile. So now you have thousands of users of your app. They all build on one common data definition, and each of the corresponding data records are stored separately in streams. And in these records, I think it's important to call out, they can either directly contain data, like the example I just showed of a basic profile. You can just dump that JSON data in a record, and it's sort of self-contained. Or you can use records as sort of jump-off points or routing mechanisms to external storage. So the record in that case would just contain a URI and potentially some other metadata, which when resolved would enable you to route to some external to IDX source of information. And that could be other ceramic documents. Like imagine you have an IDX record that says blog posts. And so in it, you just have an array of ceramic doc IDs, and each of those ceramic or stream IDs, and each of those streams is an independent blog post. So those would sort of be considered external storage, and you're using IDX as sort of an aggregation mechanism for all of those pointers. You can do the same thing, imagining it with Filecoin files or files stored on any other sort of decentralized durable storage network. You could point to Textile data stores or Orbit data stores, other centralized versions, or even on-chain contracts. And so sort of serving as this technology independent way, you can use records as sort of data stores or pointers to additional data stores, which sort of all serve to organize information. And IDX is more than just about users, as Daniel and Joel both said. If it can be represented by a DID, it can have an IDX. So, for the case of people, it's pretty self-explanatory. Organizations with the DID specifications that Joel was talking about, or however they choose to represent themselves. Content, the NFT DID method allows NFTs, which are digital content, to now have an identity and have all their information organized in an IDX, which allows them to build up this entire meta content universe that's portable and moves around with that NFT and even devices. And adoption. So Ceramic's still in testnet, but more than 100 projects are signed up for ELP, the early launch program on Ceramic. There's a bunch of big names here, and we're looking forward to a pretty successful launch. And I think I noticed that I left one slide out really quickly, but I can talk through it. And that's some common use cases for records that we're seeing already. And that's using a record as actually an authentication keychain for a DID. So you can take the DID's seed, you can encrypt it with some blockchain account, let's say, and store it in a record. And you're storing an array of effectively encrypted seed material. And so as a user, uses their MetaMask to sign into an app, that app can then decrypt the DID seed in an iframe that's secure and protected. We are building one called 3ID Connect, which allows users to sort of authenticate their DID from all of their blockchain wallets. People are using it for profiles and social graphs, user-generated content like blog posts and photos, and user settings. So, maybe a user says, I want to persist all my files to this specific PowerGate instance that's running Filecoin. And so instead of the app itself, running a PowerGate instance for all of its users' data, users can specify their own. So they're sort of bringing their files and their persistence with them from platform to platform, so they can have one universal billing where, maybe they're being billed and they subscribe to this specific backup provider that is now portable across all these interfaces. Alternative approaches to IDX, I figured it'd be worthwhile mentioning them so you can see the difference. You could, people say, why don't you store everything in the DID document? That's really hard. One, because sort of agreeing on all of the standards for all of the data formats and how to interpret the data in a DID document seems extremely difficult. And so those standards are going to be impossible to achieve for the entire data that is represented by the digital world. And so having some way to describe definitions and semantically organizing it outside the bounds of the DID document is important. Additionally, DID documents need to be kept super lightweight because they're probably one of the most synced things. Like every time you go to an app, they need to sync your DID document. And so if that document just keeps growing, the sync time increases and it bloats that document away from the critical information, which is really just the signature keys, like your public keys for signatures and encryption. Some say you use a smart contract DID. Well, that sort of ties your DID and your index and wraps it into one thing and is sort of tied to a specific blockchain network where it makes it really hard to do cross-chain interoperability and all of the sort of flexibility around data descriptions. And alternatively, I think what Daniel said is, there is a service endpoint in the DID document, which can point to a secure data store or personal data store where a lot of your information is managed on a server instance running somewhere. And all apps write and read to and read from that single instance managed by theoretically you, but in all practice by a cloud provider. And that just doesn't seem like a valid approach to decentralization, because if that server is the first jumping off point to find all your data, there's a big responsibility on that single server, even if it's replicated. So relying on decentralized infrastructure to be that first jump point, and then if you choose to route to a secure data store from IDX to store a subset of your information that you want to keep super encrypted and private on a server, seems like a better approach. So it should be like DIDs, IDX, then whatever hosted data stores you would want, rather than going directly from DID to hosted data store. And yeah, you can get started with this stuff today. So Ceramic has a JavaScript full node, which can run in browser or client side, or an HTTP API. And for authentication, you can authenticate your DID with all kinds of blockchain wallets that your users already have using ThruID Connect, or you can natively integrate a DID provider if you're trying to do something more complex. And IDX is a JavaScript SDK. So you can drop it right into your app client side and it works. And yeah, you can check out the docs, developers.idx.xyz. Our blog at Ceramic Network has a lot of good content and tutorials if you're looking to play around. And if you're interested in trying these things out, Ceramic is on testnet, so you can just go ahead and start building. But if you want to move your app to production on these systems, I would encourage you to sign up for the early launch program that we're accepting applications for now and will officially go live in a little more than a month. So that's all for me.
Fantastic. Thank you, Michael. That's brilliant. We are way over time. So thank you, everyone, for sticking around, if you are still here. If you enjoyed the talks today, then now is the time for you to put some emojis in the chat, put some hearts and claps and things in, show some love for our speakers today. Thank you so much for coming. And one last thing before we go. Here we are. Next month, we'll do the same thing. We'll do it again. Hooray. Next month is a NFT special. It is going to happen on Tuesday, April 27th. See you there. And all that's left to say, I think, from me is thank you, all of you, for coming. It's really nice to see so many of you representing, and have a lovely rest of your week, or afternoon, evening, morning, good night, and all of those things. And see you next month. Thanks for coming.